different types of devices used for the different devices. As you know, the devices are used for to close the defects. This one. So device is made up of the nitinol mesh, nitinol with the polyester fabrics. See, inside there is a polyester fabric. The upper what is the it is made up of a nitinol material. Always nitinol made up, it will take the shape, it will freeze it also. Again, it will come to the shape. That is the advantages of using this one. And material is very durable, this one, and flexible. It will not break so like a stainless steel. So it is a nitinol mesh with the polyester fabrics. So you can see some devices I put on the screen. Just I will start with the explaining device only. So you can see this one. This is the AST device here. See, first one what you are seeing is the Airtel subtle defect. So you can see here the two discs are there. So one, this is the LA disc and this is the RA disc. You can see, though always in AST size plus 14 millimeter extra in LA and the 12 millimeter extra in the RA disc like this. So you can see the here. Can you see the paper on the this one here? On the screen, my this one photo. This is a LA disc and this is the RA disc. Okay. In between waist is 3 millimeter here. Okay. For example, it's a 20 millimeter disc means LA disc is 14 millimeter. So plus extra means for 20 plus 14, 34 millimeter. And the RA disc is 32 millimeter. So in between waist is the this one. Okay. So this plus each side 7 extra means here 6 millimeter extra. So this is the AST device. Always for LA disc is bigger than the RA disc. RA disc 2 millimeter less, and the LA disc is 7 totally 14 millimeter extra in the LA side and the 12 millimeter extra in the RA side. So in between the waist length is the 3 millimeter here. Okay. For example, if it is you want to take a 20 millimeter disc, so LA disc is 34 millimeter and RA disc is 32 millimeter. So according to that, we have to select the device on the this one, because in septum, total septum and all, we have to calculate and put the device. So that is for the AST. Then so second, we have a two types. One is the regular AST and then the Kirby form AST. It is same like both. These are this one same only like AST only. Only in this one it's little closer in the Kirby form AST. So otherwise it's same. Okay. Next, what you are seeing is the PDA device. ADO, that's called the ADO1, implied that include one device. Okay. Here you can see the here this is the up to 10 by 8. You can see here there is a PDA. There is the retention skirt. It is called retention skirt. This is the aortic side, and this is the pulmonary in the duct side. Okay. So here you can see up to 10 by 8, 2 millimeter extra will be there. And this is the size of the PDA, and this is 7 millimeter length here. So PDA I can show you in this one here. So you can see the PDA device. So here, so if it up 10 by 8, so this is the aortic disc and this is the PDA, this one. So what is the 10 by 8? Make it 10 by 8 device means the here it is 10 and this is the 8 and length is the 7 millimeter and up to 10 up to 6 by 8 for the 6 by 4 and 2 millimeter total 4 millimeter extra. Mean here 6 by 8 means this is 6, this is 8, this is plus 4, 8 plus 4, 12 millimeter. From here to here it's 12 millimeter, here it is 8 millimeter. And here it is 6 millimeter. So divide 6 by 8. If it is a 10 by 8 divide, 8 is here, from here to here 8, and here is 10, and here in the IIT side is a 16 millimeter. Okay, so this is about the PDA.
Brother, this one minute. The figure you are showing, no, that is 733. No, that is what size device?
So 733, what you will see, this is a 10 by 8 device. See, 10 by 8 device means, so it is called 10 by 8 means, where is 10? This is, here my arrow is there, no? Here it is 10 from here to here, and here is the 8, and 3 millimeter extra means 6 millimeter extra. So 10 plus 6. So IIT side it is 6. IIT side is the 16. 10 plus 6. 10 plus 12. 6. Okay. And here length of from here to here is the 7 millimeter. And understood now, sir? Here this same device I will show you here. Here you can see this is the, suppose it is a 10 by 8 device. Okay, where is the 10? From here to here is the 10. 8 is from here to here, and this area what is there is 10 plus 6 is a 16 millimeter. From here to here is a 16. Here it is 10, and here it is 8. So from here to here length is the 7 millimeter.
Okay.
So understood now, sir? So if it is a 10 by 8 device, but it is a 6 by 8 device, up to 10 by 8 device, from here to here it is 3 millimeter way extra, and more than 10 it is the 3 millimeter, and 10, more than 10 by 12 it is 4 millimeter, 8 millimeter extra. So like that. So here is the PDA one. For example, is the 10 by 8 device. Okay, where is 10? This one, this is the near this one, it is the 10 here, and here it is 8. Okay, 10 by 8 from here to here length. So you can see, no, sir, here my so here it is 10, here it is 8, and this is 16. Okay, so this is 10 by 8 device. If it is a 10 by 8 device. Okay, so this is the ADO 1 device, employed duct occluder 1, and this is the ADO 2 device. In ADO device, here it is a fixed. The waist length what from here to here is the 7 millimeter. More than 10 by 12, it is the 8 by 8 waist length. Waist length from here to here, it is the 12 length. Sorry, it's 8, 7 up to 10. More than that, 12 by 10 and all 8 millimeter from here to here. So this one about the ADO2. ADO2, there is no fixed this one. Whatever it will be like that, 6 by 6, 5 by 6, 5 by 4, like that. So how it is this one? First one is the size of the this one plus 6 extra. Means second one is the 5 by 6, means 6 is the length from here to here length. First one is from here to here. For example, 5 by 6 means from here to here it is 5. 6 is the from here to his length. Length is the second one is the length. First one is the size of the device. For that first one we have to add 3 millimeter extra plus 6 we have to add. So that is the both the side it is same equal. So in PDA one only one side is the way this one the device is there. Here both the side it is equal is there. For example, it is a 5. If it is a 5 by 5 device, from here to here it is 11, and length of the device is 5 millimeter. Second one is the length. First one is the size of the device plus 6 you have to add it for that. That is the both the side it is extra 3 millimeter and 3 millimeter here. Understood, no, sir?
Yeah,
This
yeah,
one?
yes.
Okay. See, first one here in ADO2, what is there? Two sides of the device is there. So that is 6 by 6. 6 by 6 means 6 is the device side. 6 is the another 6 is the length. Second one is the length. Means the size of the both the side is 6 plus 6 is 12. It is like a 12 by 6. Okay. If it is the 4 by 6, 4 is this one plus 6 is 10 by 6 is the length. So 5 by 6 or 6 by 5. 6 is the this one, 6 plus 6 is 12. And second one is the 5 is the length of the device. Like that. According to that one, this is the ADO2. Okay. Next is some conar device. So it is BDA only. So only this even this side also there is a disc, some supporting disc is there. Okay. Then there is the VST device, when the muscular VST. Muscular VST device you can see here. Muscular VST, both the side it is equal. Say like ADO2, it is both the side there. This one, this disc and this one. LV disc and RV disc is same, not like a AST disc. AST LA disc is bigger and RA disc is smaller. But in VST, both the discs are same. And in between waist length is the 7 millimeter here. Okay, 7 millimeter in between waist, but in AST it is 3 millimeter waist between waist length. And the here what is there smaller like a up to 6 mm, it is a 2 millimeter, 4 millimeter extra. Means if it is a 6 mm VST, LV disc is 10 millimeter, RV disc is 10 millimeter. Okay, so mid portion is the 6 millimeter. Okay, so in waist length is 7 millimeter. So more than 12 mm, it is the waist length will be the 8 millimeter, and this one will be the 4 millimeter extra. Okay, 8 millimeter extra. So 12 millimeter VST means 12 plus 8, 20 millimeter LV disc. RV disc will be again 20 millimeter. Waist length will be 8 millimeter. So this is the muscular VST. We have three type of VSTs. One is the muscular VST. Another one is the perimembranous VST. So perimembranous VST, we have three types or two types. One is the symmetric and the asymmetric device. So what is the difference between the perimembranous symmetric and asymmetric? So here you can see the symmetric and the asymmetric here. So both two discs are there. So, but like a muscular VST, here this is the muscular VST. You can see this is the symmetric and the asymmetric here. So symmetric is the both this one is equal, and the waist length is 3 millimeter, and the asymmetric is the eccentric device. So one disc is lower, another disc is upper. Why you have to use this eccentric device? I will tell you. So if it is very near to the IT cusp, it will rub the device. So only one is the asymmetric is the eccentric device, and this is the symmetric is the both this one, but both the device waist length is 3 millimeter. But muscular VST waist length is 7 millimeter here. So we have one is the muscular VST, another is the perimembranous VST, symmetric and the asymmetric. Okay. So this is used for the VST. So we have to close the VST. What all device can be used? One we can use the ADO2 can be used. If it is a very small, less than 2 millimeter, 2.3 millimeter, less than 3 millimeter, you can use a ADO2. So it is as it is very small and it is very smallest profile device, you can go through the retrograde approach. Like you can use a pipe wrench guiding catheter and you can cross the VST from LV side, and we can keep it in the pulmonary artery and push the device. You can use a smallest this one, 5 French guiding catheter. You can use it. Only this device can be used with the guiding smallest 5 French guiding catheter. All other devices you have to use a sheath only. So with the retrograde approach only, you can use this device. So to close the VST, it is a perimembrane or the subaortic VST less than 3 mm. You can use the ADO2. Then it is the subaortic VST. You can use a PDA1 also. Same ADO1 also can be used because the LV pressure is more. If it will correct device, it will be use it. So it will sit in the subaortic VST. But mid-muscular VST, you have to use a muscular VST device only because sometimes it will slip otherwise. Okay. So this was the mid-muscular. So either you can use a ADO2 or ADO1 or the muscular VST. If it is a perimembrane, is see if it is the defect is very near to the articles, we have to use a eccentric device. That is the asymmetric device. So either for VST you can use a asymmetric device, symmetric device, and the PDA1, PDA2, and the muscular VST. That are all the devices used for the VST device. Okay. Then another one is the PFO device. So you can see the PFO device is the AST device. RA disc is smaller and LA disc is bigger. But in PFO device, correct ulta is the PFO device. This one here. So you can see the this one. This is the LA disc is smaller and RA disc is bigger here. Correct ulta from AST this one because RA pressure is more, LA pressure is less in this one. So only normally you have to say for PFO device. So LA disc is smaller, and the RA disc is bigger device. And same like AST, there is a 14 mm extra in the RA and 12 mm extra in the LA here. Okay, this is the PFO device. Okay, so and you can see
which one in this figure, brother? Which one in this figure?
PFO device I will show you in the next picture. Here it is not there.
It is not there. Okay.
It's here. This is here. You can see the this is the cribriform, and here you can see this is the PFO device. You can see here. So this is the RA disc, and this one is the LA disc here. Okay, so LA disc is smaller than the RA disc here. But in the AST, cribriform, one more device I told that cribriform device, both are equal. It's the same like this one. The here again, this is the cribriform AST device. Some say penetration, this one and all, this is better to use this one. Otherwise, almost same. Equal, little smaller there this one, but it's equal here. Both side equal here, but in regular AST, LA disc is bigger. Okay, so that one is the PFO device is the LA disc is smaller here. You can see this disc is smaller. Okay. So this is the one more. This one I think you have not seen earlier. We have used also when Vijayalakshmi madam was there. You have used some devices, knit occluder. It is same like coil. Coil is wrapped over this one. It is looking like a device, but it is not a device like a coil. It is called knit occluder. Okay, even for PDA also you can use it. Even VST also you can use it, but PDA normally will use it. We have used for the PDA sometime when Dr. Vijayalakshmi was there. We have used. Nowadays you are not using and no, are not getting also. But this is the knit occluder. Okay, this is the AST. This is the PDA1, PDA2. That is ADO2. That is conar device, and this is the both are the VST device. Now you can see the This is again PDA
There, what
device.
is that last one? Last one, the left lower one. What was that?
What was Nitta cloud? This one you are telling, is it?
Next. No, no, no. Next one.
This one?
No, this side, towards the left.
Yeah, this one, no, left. Left one again VST only. It is a Sierra. Color itself, you can just, color is different color, no? The LifeTech Sierra device, somebody it is the same VST device. Okay, same, it is same like this. We have kept state. So it is the Sierra device, regular LifeTech one. Okay, you can see again here. Can you tell what is this device? Just I have shown for you.
ADO1.
ADO1, correct. This is a ADO1. You can see here. So, for example, now I can show you clearly. You suppose you think it is a 8 by 6 device. 8 by 6 device mean what is this? This from here to here it is 8. Here to here it is 6. Okay. Plus 2 plus 2, 4 millimeter extra. Mean from here to here is the 12 millimeter. Here it is 8 millimeter and it is a 6 millimeter. From here to here it is the 7 millimeter. You can see here now this is the 7 millimeter.
Which one is 6?
6 one is this one. This arrow you can from here. My arrow is there, no? I am moving from here to here. It's a 6. So suppose you think it is the 8 by 6 device. Okay, 8 by 6. In LifeTech they are telling 6 by 8. Okay, this is ulta they are telling because of the patent issue. Okay, this emblazer they are telling first one is the they will tell the bigger this one. So 8 by 6. In PDA, some we have some difference. This is 8 by 6 device mean 8. So my arrow is moving now from here to here is 8. From here to here to here is 6. And here to here is the plus 8 extra. Means 8 plus 4, 12. 12, 8, 6. Length of from here to here is the 7 millimeter. Okay. So 8 by 6. If it is the 10 millimeter, this one, 10 millimeter, here it is 10, here it is 8, plus 3 millimeter, 6 millimeter extra, 10, 16. ITIC side, it is the ITIC side 16, 10, and 8. Okay. If it is the 12 by 10 device, 12 by 10 device, 12 is from here to here. Okay. My arrow is moving 10, 12, 10, and here again the 6 millimeter, 6 millimeter extra, 16 millimeter. ITIC side 16, 10, 12, 12 plus 6, 16, 12, 16, 18. From here it is 18, okay, 12, here it is 10, and from here to it is 8. Length of the device is the 8. So more than 12 mm. So it is increasing. So it is like a PDA 1. This one. You can see the chart also here. Smallest device up to 8 by 6. It is the length of the 7, 7. Means length means this is 7, 7. And here this is the first one is here. Second one is here. Plus 3 millimeter extra. More than 12 by mm, 4 millimeter extra. This side 4, this side 8 millimeter extra. Okay. So, this is the PDA 1. Again, it is the creepiform AST. This for the AST same, both are same. And this is for the PFO device. Okay. Now, this I am showing this one. What is the device? This one, perimembranous device. So, membranous, perimembranous device. It is for the VST. This is for the RV disc. This one is the RV disc. Okay. Here it is the eccentric. 0.5 mm less because your aortic cusp will come here. So to avoid the aortic cusp rubbing, they have make it eccentric here. And this side it is long. both the side is equal, but one side is eccentric, another side they have done a longer this one. So it's called the asymmetric device. Asymmetric VST device, and in between waist here the is the 3 millimeter. From here to here it is the 3 millimeter, and for example is the 10 any this one, sir. So this is the asymmetric perimembranous VST device. Okay, one side array disk is correct. This one is eccentric. This side you can see it is not reaching the side. Okay, it is eccentric here, and this side it is longer. Both disk is equal, but one side is eccentric, and this side this one is the waist length. So this is for the perimembranous VST. Another the VST is there, that is the symmetric device. Same like, but it will be equal. There is no eccentric. That is the symmetric device. Perimembranous symmetric device. Okay. So that is for the perimembranous only. Only for the this one eccentric, if you want to use, you have to use this one. Again, is the PDA same like this one you have shown you. So then is the ADO2 device. Here you can see, I will tell you, if it's the 4 by 6 device, what is 4? So I will show you, this is the 4. From here to here, it is 4. 6 is from here to here, length. Okay. Then what from here to here, how much it is from here to here? Plus 6 extra. Mean 4 plus 6 extra. Mean from here to here 10. Here to here it is 6. 4 by 6. It is a 5 by 4. If the device is 5 by 4, 5 is this one, 6 here, plus 5 plus 6, 11, plus 4 is the length. 5 by 4 means. Okay. So second one is the length. First one is the size of the device defect plus 6 millimeter extra. That is ADO2. Okay. So again, this is the PF4 device. You can see the disk is this one. Creepiform occluder, it is a for the AST. Normally for fenestrated and all, we will use this one. Okay. Then muscular VST occluder is the same one what I have shown there. So you can see this one here, the length, waist length is 7 millimeter. Again, this is the bigger device, 4 millimeter, 4 millimeter extra here. Okay, waist length is this one. Okay, this is the muscular VST. Again, this is the so then we will move to the
Hello. Hello. Brother. Varun. Varun?
Hello. Hello.
Brother, you're audible.
Audible, ಅಲ್ಲ? So, sorry, sir, because of there's some this one I think keyboard disconnected. So this is the vascular plug. Vascular plug 2, 1, 2, 3 ports are there. So that's a Emblager vascular plug. That it can be used for the embolization. This one, we may be AV fistula, cameral fistula. Sometimes can use it to close the napka, napcord. There we can close it. So even like a tubular type of hello, hello.
Brother, you are audible.
Whatever. Okay. So even for the tubular type VST, this one PDO also sometimes you can use. This is the Emblager plug, vascular plug. Vascular plug 1. This is the 2 again. This is the vascular plug 3. So only this one, see, all are this one, see, this vascular 3 and 4, even smallest profile, even with the guiding catheter, we can go. So that is the advantages. These are the vascular plug for the embolization. Okay. So we're now home to intervene. So you will see the your internet connection is some problem. Your internet unstable. It is showing again. Anyway, otherwise I will switch over to the laptop. Just I will try. Okay. So AST, VST device, AST device, VST, PDA, and the RSOV, AP window, and this and all can be couched with this one. So the one we will discuss by the device closure of the AST. So the coming to the introduction, septal defects are more common in the non-cyanotic heart disease. Most common congenital heart disease in adult. Basically, it is open in the intra-atrial septum due to the deficiency in the septum tissue. So definition is the holes of variable size in the intra-atrial septum and atrioventricle or the intraventricular septum enable blood to centered between the left and right side of the heart. So you can see the AST here. This is the left to right shunt is here. So we have a ostium secundum and ostium primum and the sinus venous type of ASTs. So ostium secundum occurs from in the central portion of the septum. Ostium primum is occurs immediately above the AV valves and open associated with the cleft in the anterior wall leaflet. It is more common in females. Sinus venosus type, it occurs near to the orifice of the superior vena cava and the often associated with the anomalous pulmonary venous drainage. So you can see this one. This is a secondum. This ostium secondum where AST. So this is the sinus venosus type in the SVC type AST. So can we close all the this one AST? So normally only ostium secondum with a good margin. So all can we close the all types of on this one, all large size ostium secondum AST also. We can close up to 36 mm. So maximum size available is the 36 mm. If we have a very good rim, we can close if the maximum size available is the 40 millimeter. If more than that, if you want to close, we have to ask the company people for the custom-made device. Maximum 45 up to 46 mm they are giving, but your septum should accommodate the device. So only maximum availability is the 40 mm, means around 38 mm device defect can be closed with the 40 millimeter device. Okay, this one. So that is this one. More than that, we have to send for the patch closer only. 200% of size of this one. Then minimum 10 kg weight will do from this one, in pediatric. More than that, less than that, we will not do this one. So here this three types of this one. Only secondum we will close. It is the again the deficient for you can see in the this one rim one. So less than 10, more than 10 kg only will with a central defect with a good rim and Actum primum will not do and sinus venosus we will not do for the not suitable for the device closer. So then we will do the procedure. So what we'll do, I need not tell, but still this one I will tell. So first we will take a right heart catheterization, like we will use a multi-purpose catheter, and will very important we have to take the pulmonary artery pressure to assess the pH. If it is a severe pH, we will not do this one. Then the reversible. Then we have to think over the reversible or irreversible pH. So then, we have to record the pH pressure. Then 0.035 thermo guide wire with multi-purpose catheter will introduce to the right femoral vein, and will enter we have to enter all the pulmonary vein actually. Why? Because if there is a PAPBC, we have to rule out. Then normally we have to enter the left superior pulmonary vein. Why? See, normally we will try to enter the left inferior left superior vein sometime. Sometimes it will go deeply to the pericardium. So many times it happens. So only we have to try the upper superior left pulmonary vein, or we can go to right superior pulmonary vein. So normally we will try with the superior left pulmonary vein. We will keep the thermo guide wire with multi-purpose catheter in the left superior pulmonary vein, and exchange with the, if it is the pediatric case, we will keep a regular exchange wire. Otherwise, we have to get a M-plage extra stiff 0.035 into 300 centimeter or 260 centimeter extra stiff wire, and we have to anchor in the left superior pulmonary vein. Okay, pulmonary vein. Then we have to take a correct size delivery sheet according to the what size of the device you have selected. That one you have to this one. Then how will that delivery sheet and the device you have to how will select the device. this one side, then how will we have to size the device? One is the with the TE, this one guide with the TE we can do, or the transthoracic and the transesophagus. This one we will, if it is transthoracic and you want to put the device, normally 5 to 6 millimeter extra you will take. Then if it is a esophagus, this one we will take a 3 to 4 millimeter extra device. If it is a balloon sizing, we will take a 2 millimeter extra. So how we will do the balloon sizing? We have a two types of balloons. This one is the static balloon, another is the occluding balloon. So you can see that this is the, what you are seeing is the static balloon. So but that is the balloon sizing. Static balloon means you will inflate the balloon. First we will enter the in the superior pulmonary vein and anchor the wire in the superior pulmonary vein. This one. Then we will pass the balloon here and across the defect in the septum we will inflate the balloon. We will get the waist here. Here one waist is there and here in one waist is there. We will measure this one. This balloon has got 10 mm marker and 15 mm marker. We will take this as a reference, 10 mm, 10 mm. I will measure in the vessel sizing option is there in the system. You can measure from here to here, and 2 millimeter extra you can take the device. For example, from here to here, if it is this is you can see the marker here. This is the 10 mm. This is the static balloon is 10 mm, and from this one is 15 mm. We will take this as a reference as a 10 millimeter, and we will measure this one here. And if it is 20 millimeter, we will take a 22 millimeter device. Okay. So otherwise, T guided or transthoracic plus 5 millimeter extra will take. It is the rim is adequate. Both the rim SVC and this one or bicaval rim if adequate, you need not go further. The E also you can do it. Otherwise, the balloon sizing is the accurate. You can take. We will measure the waist and you can go with the device. This one. So we have another balloon called the occluding balloon. What is that occluding balloon? So it is an oval shaped balloon. Here you can see oval shaped balloon. We will inflate in the left atrium. Same like we will inflate in the left atrium and we will pull the balloon across the septum. So we will full volume we will put. Slowly, gradually, we will decrease the volume in the syringe. When it slips, this inflated balloon slips with the tug in the AST. That volume will measure outside, and we have a sizing plate: 10 mm, 12 mm, 14 mm, 16 mm, 18 mm, up to 38 mm sizes holes are there. In that balloon will what volume we have inflated inside, same volume will inflate outside also, and will fit that balloon inside that hole. Whatever hole is matching, that is the size of the AST. That is called occluding balloon. Occluding balloon is this. This is the static balloon. Two types of balloons are there. One is the static balloon. This is the across this one, and is the occluding balloon. We will inflate in LA. We will pull up to the RA. When that balloon slips with the tug, that volume we will inflate outside and we will match in the sizing plate. That is the.
Brother, how to come to know with what volume it has got the size that is with which it is slipping out?
Which one? See, which one? This in the static balloon or occluding balloon?
In both.
Both. See, here you can see, no sir. There is a waist. Can you see the neck here?
Yeah, this you will measure. This you will measure on monitor, or where you will measure?
This one will measure in the monitor.
Monitor only.
We have a computer. This like a QCA. We have in computer. We have a QCA, no? Quantitative coronary analysis and vessel sizing option is there. Vessel, we have two types of measurement. One is for the coronary. Coronary that we can take as a guiding
Catheter
catheter
size.
as a reference. Catheter size as a reference. Here that is a this one size of the reference size. This what will do that the computer will take like a, it will ask what length. We will mark it here 10 millimeter from we will select as a 10 millimeter and we will drag the line from here to here. This is the 10 millimeter. Then we will click it, calibrate. Then it will take a reference as a 10 millimeter here. This one from here to here it will take, or from here to here 15 millimeter. You can take. Here also you can see, no sir. So this is the 15 millimeter here, and another dot,
Okay.
that's the 2 millimeter. Computer will take this as a reference. Okay. Even manually we can measure. Like see, you will take a, if your computer doesn't have this one measurement. Normally, what happens no, in the private, say when I'll go to Shimoga and Mysore, there was no option earlier. So what I'll do, I will take a paper here. I will put a dot from here, paper from here to here. I will take it as a 15 millimeter, and I will divide as a 15 marks. I will put divide 1, 2, 3, 4. I will divide into 15 millimeter. Then I will measure from here to, that's the waist. If it is, that is 15, then I will keep that paper from here to here. Okay. Then I will measure 1, 2. You can take a scale 1, 2, 3, 4. So like that. It's manually also you can measure. If you take that 15 millimeter as a measurement, here that dot is not seen. Otherwise, I would have shown you. This is because of the dark, this one picture, the mark is not seen. So
Okay, that mark is usually seen, no?
yeah, usually seen. Because of this dark picture, this is taken, this one is not seen only. Okay, normally you can see. Okay.
Okay.
So that marker you can take it as a this one, and we'll take it as a reference and measure the over the computer. Or if it is a static balloon, if it is a occluding balloon means we will inflate in a laser. So so if it is suppose it is a 24 mm, you will take the 3 types of balloons. You can inflate up to 30 millimeter. Then we will pull up to the defect here. It won't come. Gradually we will reduce the volume in the syringe until it slips. Slowly 1 cc will reduce fully. Another 2 cc reduced full. So when it slips with time, when I see, if you will go on reducing slowly, it will clip once. Whatever volume you injected inside, that volume will inject. Then we'll throw that extra volume, whatever is there in the syringe, we will throw it. Then we'll deflate the balloon. What volume you injected inside the balloon, that one will pull the balloon outside and will inject again whatever volume injected earlier. That volume inflated balloon will match it in the sizing plate. Understood now, sir? That I will show you once, because there was, I have a sizing plate also there with me. That I will show you how we will matching this one. So whatever hole it is matching, that is the size of the AST. That is with the sizing. Earlier we used to do for all cases. Nowadays, because of T is good, you are doing like that only. But earlier all cases, you used to do balloon sizing only. When you started our AST device closer, never our device slipped. Because if there is a, I will tell you, if there is a deficient rim, this waste won't come. Okay, in balloon sizing. Balloon sizing, this waste won't come. Then you have to think there is a some deficient rim is there. Okay, that is the sign of this one. Then we'll think, see, we have to take little bigger device like that. Okay, so this is for the sizing balloon. We will size the with this one. So then we'll take the device. So then again, what is the contraindication? See, sometimes if we have a deficient rim, it is there, the rim is not there, will not be able to do. Then if there is a superior rim, this one, so you can come from the right superior vein sometimes, or balloon assisted. You can keep a balloon side by side, and we can keep a wire across, one more wire we can keep, or bad technique, balloon assisted AHT device closer. We will keep the balloon side by side, one balloon, and deploy the device. Then slowly we can release that side by side balloon and pull it back. Then bad technique, that is the balloon assist. If there is a deficient rim in this one, so you can do the bad technique. That is called the balloon assisted AHT device closer, balloon assisted technique. So we can give this one. One we can do. See, first we'll try with the left superior pulmonary vein and deploy. Because of the deficient rim, sometimes it will clip out. Then you can try with the right superior pulmonary vein. Okay, so you can try with the right superior pulmonary vein and deploy. Sometimes it will sit. Still it is not then. Then you can try with a bad technique, that is the balloon assisted technique. That you can keep it, do it. So that is the different types of doing this one in the deficient this one. You can see the echogram, this one, it's a measure the size and rim also you can see in this one. So same thing this one. So what are the different types of devices for this one? So you can see that this is the emblazer device here, and here this is the air device. This is the umbrella type device earlier one, this one. Okay, umbrella type device was that is the LIDs and this is the array. Okay, this is again the Sidris button device. This is called the button device. Earlier what all these devices were there. Then this is the angle wing device, the guardian angle device. This one. Then again this the cardioform helix device. This one. Then cardio seal starflex device. This one. Okay, cardio seal. These are the devices can be used for the AHT, but normally we are not using all these one device. It's all the cumbersome. This is a very easy to use. Is the emblazer and the LifeTech device. Okay, it is the same popular device, LifeTech from the China, and this is from the abroad, FDA approved this way. These are the older version devices, but still some people are using the one, but little cumbersome devices. But the devices are available. These are the different types of devices. So again, see, normally some also core cardioform devices using an emblazer and the LifeTech devices. So this one is the AHT device. This is the PFO device again. So for the PFO, this device is this one is smaller, and this is the RA disc. This is the again LA disc. So again, this is the cardioform device closer. So this is the AHT device closer. You can see this is the LA disc, and this is the RA disc. So this is the way this one. Very important is the LA disc is 14 millimeter extra, and this one is the 10 millimeter extra. So before using the device, you have to measure the total septum also. Very important. Normally in the adult, that problem is not there. Only for pediatric, sometimes defect itself around 18 millimeter, or total septum is 18 millimeter, means it will be 32 millimeter total septum minimum should be there. Okay, but if the total septum is 28 millimeter, we can't use that device, because this LA disc will be for 18 millimeter, it will be 32 millimeter. So if total septum itself it is the 28 millimeter, we can't use it. Then the bulky device, it will go and sometimes it will impinge the LV, or it will not sit properly. That very important. Total septum also you have to measure. Normal in pediatric, we have to measure the total septum also. Adult, that problem will not be there. Normally 48 to 50 millimeter it will be there. So, but in pediatric, very important. Along with the total device size, total septum also you have to measure. Very important. Then this one, another thing, if there is a pH, how we can whether we have to close the AST or not. Then we have to take the one we have to do it is reversible or the irreversible. So what we will do, we will keep one balloon in the AST, will inflate the balloon in the AST and another catheter in the pulmonary artery. Simultaneously, we will measure this one if it is dropping or not. PF the drops, we will do the device closure. Then not only the tip, sometimes pulmonary artery pressure drop, but can we do the device closure? We have to check the LVEDP also. Sometimes LA overload, then it will be a problem for the patient. LVEDP also should not elevate. Or LV, so you have to take LVEDP simultaneously when we are inflating the pulmonary artery pressure drops, even LVEDP also elevating, so we should not do. Pulmonary artery pressure is dropping and LVEDP also same, then we can, it is a irreversible pH, so you can do the procedure. Okay, then for the this one contraindication and this one. So how we will load the device? You can see this one, we have to load the device in the flush only. So the saline we have to keep it, and this is the two types of loaders are there. One you can see they are the along with the delivery system they will give on the loader. Otherwise you can use our own sheath. Our own sheath is better than this one because you can flush it properly. Air bubble you can remove very easily, and always one side lesser than what delivery system you have taken, that one you have to think. Then normally up to 18 mm device, up to 12 mm 8 French sheath is enough. Up to 18 mm 9 French device delivery sheath you can use it. And more 18 to 24 10 millimeter delivery sheath. This one 10F delivery sheath. And up to 24 to 30 millimeter, you have to use a 12 French delivery system. More than the 30, you have to use a 14 French delivery system. So according to that, you have to select a delivery sheath, delivery system. So one side, the lesser this one, this loader you have to take to push it inside. So always you have to keep load in the saline only to avoid the air bubble to go inside. And again you have to flush thoroughly. And while pushing the device also, you will be through the with the fluoroscopy only you have to push it, because if there is a air bubble you can see in the fluoroscopy. Okay, that is the very important in the delivery this one. So it is you are flushing inside the saline and slowly you are pulling it inside. You can see. So to avoid this one, here you can see this one. If there is a this one, you can go deploy the device from the right superior pulmonary vein also, and normally will come from the left superior pulmonary vein. Here you can see the device is deployed in the left atrium because it is not totally open, because there's still that device in the pulmonary vein. So just to have to, as a system you have to pull it, then it will take the shape. So now it is see we have pulled it. It is in the this device. This is in the left atrium, and this is in the right atrium. We have pulled it. So because of this one, we have taken a little bigger device, because only it is not showing properly. But can we have the see this Minnesota wiggle we are doing? So only it is looking like this. So here you can see the again it is not seated properly, because here this one is abutting here like that. Again we have done again we can recapture it and do it again. Okay, if they have any doubt, or you can see in the echogram if any this one is there, or with the position also you can see. So in the LAO, if you come to AP view, you will get a oval shape. So that is the correct position. Okay. So then if after confirmation with the 2D echo, you can release the thing. In the AP view, you can see this is, you can see again we have recaptured and done because of the not this one. See again from the right superior pulmonary when you have come, and it is that distal portion is in the LA. So now we can confirm in the echo also. Afterwards we have deployed. See, after deployment in the AP view should overlap each other. See, you can see the two dots here, and this LA disc, and this one should be overlapped. If it is like this, it is a correct deployment. You can see here. Okay, so this is the correct deployment. These the two dots are there, and it is overlapping each other. It is in the AP view. It should look like this. It's the correct deployment. This is for the AST. Okay. So any doubts, sir? Next, we'll move to the this is the bigger device what we used in the cross section in the surgical. This one we can see in the this one. Okay, then we'll move to the VST. So vertical septal defect. Say Henry Roger was the first man to describe the vertical septal defect in 1979. He this one, I think it's timing. I think I will go a little fast. I won't explain this and all because you are better you know than me. So this is the muscular VST. You can see here.
This you can go skip, brother, because
yeah. So only I am skipping this one. I will. I don't want to show this one and all because you are better than you better know of this. Only devices I will show. Okay, this is the VST closer devices. So clamshell and the cardio seal device is there. Cardio seal Starflex. This is also better device from the Boston Scientific. And this is the Emplager type of device I told you. See, what are the different types of device I already explained there. So we can use a ADO1, ADO2, and muscular VST, perimembranous section, asymmetric and symmetric device can be used. So and nitoclouder also. So you can see the this one. So this is the perimembranous VST. You can see that this is the eccentric type. Okay, and this is a nitoclouder like a coil. We can use it for the perimembranous this one. Okay, that obstruction that IT grub will not be there. And this is again the this is the muscular VST again. This is the Emplager muscular VST. The waist is here 7 millimeter here, and this time this side another 8 millimeter extra for the muscular type of VST. You can see the this one. This is for the ADO2 for the smallest this one. Less than 3 mm you can use a retrograde approach only. You can use this one. This for the PDA one device can be for the robotic VST. You can use it, and this is the muscular VST, and then this is the nitoclouder for the VST device. Again, this one is the perimembranous VST for the this one the eccentric device, and this one is the symmetric, and this is the asymmetric device. Again, this is a conal device. It's the same like PDA, but some this one is both the sides, some waist is there. Again, this is the perimembranous, this eccentric, and the asymmetric and the asymmetric device. Muscular VST again. So we can close with the antegrade as well the retrograde approach. So antegrade approach is directly you can go from the venous and right pulmonary vein, and directly you can cross also the VST. You can cross it, and you can deploy the distal portion of the device in the LV apex and pull back and deploy in the RV disc. Sometimes otherwise you have to cross the VST from LV side So you have to keep a right Judkins catheter and a thermo wire 0.035 that angle thermo, and directly you can enter the VST and keep the tip of the thermo guide wire in the pulmonary artery or the SVC, and we can snare it from the venous end, and from the venous arteriovenous loop we can keep it, and over that we will put a delivery system. So your delivery system should go to the descending the ascending arch of the aorta. Then you have to take the device partially, you have to inflate deploy in the ascending aorta. Slowly you have to pull back and cross the aorta and deploy totally. The distal part of the device should be opened fully. Then pull up to the septum and deploy the proximal RV disc. Okay, so that is for the antegrade approach. Retrograde approach, if it is the smallest this subaortic VST, then we can use you can cross the VST, then you can pass or ride 5 French guiding catheter and keep it in the pulmonary artery. So the tip of the guiding should be in the pulmonary artery. Then you can pass the EDO to this one device, deploy it distally, pull up to the septum, and to deploy the proximal part in the LV, this LV side. That is the retrograde technique. So both the technique is very feasible. You can do it, but if it is a very small only, you can do the retrograde technique. If it is a bigger this one, you can do. You have to do the antegrade. Maybe you have to cross from the left aorta, but you have to do it from the antegrade technique only. So for that, same like JR on the multipurpose catheter to cross this one. Then pigtail catheter, again marker pigtail also can be taken to sizing, accurate sizing you can do. So normally for the subaortic and the mid-muscular and the apical VST, you have to do a 60-degree LAO and cranial of 20 degree, or hepatoclavicular view like a 35-35 or 30/20, cranial of 20. That is the hepatoclavicular view. Two views to be taken. One is 60 LAO, cranial 20 degree. You can see the VST properly. Subaortic VST, mid-muscular and the apical VST. And if there is any, if you have a doubt, you can get a hepatoclavicular view like a 30-30 or 30/20, 30 LAO and 20 cranial view. That one to be taken and to visualize the correct size. So if it is a marker pigtail, it is a very good pigtail to measure the size of the this one VST. So we can do the LV angio, proper LV angio, and assess the size of this one. According to that one, 2 mm you can take a extra and decide you have to go from antegrade or the retrograde. Okay. If it is a subpulmonic VST, there is no choice. You can't do it. You can do it subaortic, perimembranous, mid-muscular, and even apical. We can do it. Okay. In post-MI VST, sometimes we will wait for this one. Immediately we will wait for 1 month, or if it is a very emergency, we can hybrid procedure can be done. So you can take the device to the OT. They will open the this one heart, and they will show the size of the this one. You can measure there only with the caliper and put the VST device inside and pack it. Put it into this one. You can take a smaller sheath in that, and we can load it inside and put it inside the VST, and they will close this one with the hybrid procedure. With the hybrid procedure. Okay. In OT only you can deploy the device. You can see this is a mid-muscular VST. You can see here. This is the mid-muscular VST around 10 mm VST. You can take it 12 or 14 mm VST here. You have to take mid-muscular VST only. So this septum will be 7 mm from here to here. So what you have to do, you have to cross the VST from right Judkins. We have to take a right Judkins with a thermo wire, cross it, and you can keep the tip of the wire here and near it, or you can keep in the SVC and near the wire, and you can pass the delivery sheet from right femoral vein only, and deploy the device. You can see the here, this is the device, the VST, muscular VST only used it. So this is the device, muscular VST device inside the this one. So this disc is RVT disc, and this is the LV. You can see here. This is again, this is a smaller disc from the integrated approach, right? This is the guiding catheter, 5' guiding catheter. This is the EDO2, the device deployed in the from the integrated approach. You can see there, this one here, here this across the, this one. Only problem is in the EDO2, immediately it will not close because that polyester fabric is very less. Only in the mid portion they have put this one. So only it is very lower size defect. The polyester fabric is very less in the EDO2. So it will take time to close the defect. You can see again one more case one. This is the EDO2 used here. Okay. So this is in the RA disc, and this is in the septum. There is a this one septal aneurysm also there. Again, this is the EDO1 we have deployed for the subaortic VST. You can see here. See, distal portion is in the LV, and here yet to deploy. You can see this is the EDO1 here. This is this is the retention skirt, and this one is in the RV side. Okay, then we'll move to the PDA. Is it late, sir? Then this is for the PDA. So you have a different types of PDA. You can see with the conical shape of PDA. You can see here this one. So the PDA, this one, this is the conical shape, and this is the window type. You can see this is the IATA and PA. This is the B type, this is the window type, and this is the tubular type of the VST, the PDA. And this is a complex type. See, again, one more construction is here, another construction is here. So with this one, you can see what device to be selected. So this is this one you can see along, and see again it's a long this one is here, and elongated PDA you can see here, see this one. So with seeing this one, you have to select a device. What device to be selected? This is the conical shape that the ampulla is there. You can take a PDA as usual. You can PDA you can take. Okay. This one also, this is the window type. Little bigger you can take if it is a this one you can take a VST device also, or some conar device can be used, because here some hold will be there. So this is the tubular type VST PDA. For this one, you have to use a EDO2, and EDO2, it is a smaller, less than 5 mm. You can use a tubular type. You can take a 6x6 longer there. This one you can use it. So it will pull it. So both the side disc will come here and here, and there is ampulla is the very less here. So EDO2 will be ideal device for this one. And here this is the complex PDA. Again, one construction is here, another one is there. What you can do, you can pull the device into this one, and you can use a device here. Either otherwise, EDO2 will be ideal. This mid portion will come here, and both the sides there is a this will come. So EDO2 also can be used here. Okay. Again, this is the conical shape. So you have to measure this ampulla here. You have to, according to this area, you have to select this. I think this should come here, and you have to use the device. Even EDO2 will be the idea in this one, or you can use a PDA1. So list we have to, according to this side, you have to take this one. This is the type, different types of PDA. You have to select the device. Okay. So you can see here it is a smaller, less than 3 mm PDA. You can use a coil. So this you have a, according to this one, you can use a smaller 3x5, 5x5, 8x5 coils are there. You can use a coil less than 3 mm. More than 3 mm, you can use a device. You can see that how coil has sit here in the this one. So smaller, this one you can use it the coil, and the bigger device you can use a device. Okay, so but you have to go from the integrate approach only. You have to first you have to cross the PDA with the multiple. First you have to do a angiogram to confirm what size of the PDA and what type of PDA. So in the left lateral view you have to take to assess the this one you have to take a, otherwise you have to take a RAO 35 degree. If it is the correctly it has come sometimes some anterior PDA arrest from anterior and posterior, then you have to take a different two views. One first lateral, left lateral you have to take, then you can take a RAO 35 to 45 degree to assess the correct size of the this ampulla and the this one. Always we have to measure the ampulla first, then measure the PDA, because in that ampulla that the retention skirt should sit. According to that, we have to take a device. So if it is little bigger, also no problem. But in this retention skirt should sit in the ampulla. If it is the bigger device will take, it will not sit in the ampulla. It will hang in the aorta. So very important. Ampulla should be measured first, then the PDA size. So PDA size little bigger also no problem, because that will accommodate in this one. Some waste will come in the PDA, and pulmonary artery side some waste will be there. But ampulla we have to very important to measure the ampulla. Then that the aortic side disc retention that should sit in the ampulla. So you can see here. So this is aortic arch injection. You can see first you have to measure the ampulla here. This is the PDA. Okay, if it is around 14 millimeter or 16 millimeter, then what size you can do? 10 millimeter device, 10 by 8 device it will use. Aortic side will be 16. This ampulla we have so correct 16 will sit in this, and here 8 millimeter will sit here. So this is the, according to this one you have to select the device. Okay, so again this is the device. You can do the in the RV angio in RAO view also will be this one aortic arch angio. It's a device seated in the ampulla. So you can slowly you can pull back the delivery system. So you can see the device is seated in the ampulla as well as the PDA. Okay, so this is for the PDA. Okay, if you have time, then otherwise I will I have so many this one, even all other interventions also there. But I don't want to do this because you have another meeting you are telling.
Yeah. Still, what all are there, brother?
No, so but so many other interventions, BPV, this one, everything is there. VST, this one also. So
Okay.
I don't want to this one because if you have another class, I will discuss, because so already 7 o'clock now.
Okay,
So
we'll discuss some other day.
You can see the again one more PDA you can see here. Very important things you should know this one. This is the smaller PDA. We have used a coil here. See this one, this one. Here you can see this is a large, for the pediatric case only, large PDA. So in that situation, what you can do, if we will use a regular PDA device, it will occlude the aorta here. So for that, what we can do, you can ask the company people to do a custom-made device. So see, normally for pediatric, this one, if you use a bigger device, it will occlude the aorta. See, you can see the here this angio. This is very large PDA. If you use more than 10 mm, it will occlude that. Then this is the angle device. It is so that upper device they have cut it. This is the specially made for the. This is the angle device made for the. This one earlier nowadays we have not see when Vijayalakshmi madam was there. We have done around 10-15 cases with this one. So Engel device. For the pediatric case only, a bigger device we have used. That's called an Engel device, custom-made device. This so specially made. It will send the IIT angiogram to them. They will make a custom-made device for that. This one, IITA. Okay, for PDA, to close the PDA. So that is the custom PDA device. Then I will end the session today's this one. So that other intervention, so we'll see afterwards, because so many are there, and it will take another half an hour, because I can't.
Okay, brother.
PBV ಇದೆ ಮತ್ತೆ cooptation ಇದೆ, ಆಮೇಲೆ cooptation apart PBV and this and all there. So I will discuss. So I don't want to waste your time.
Okay. Another one class is needed, brother.
So if you want this one, the devices, okay. PBV, ABV is there, that I think that is not necessary to be, to this one. If at all anything you want, you tell me. See, I will even I was sent the OCT. If you want, I can show the tomorrow. Not tomorrow, Monday.
IVS we will see. Not so important, I think, for our exams.
Definitely, but they will be now, or imaging. They will ask.
Imaging, they will ask. I think actually some class. Chadda sir is there, no?
Yeah. Chadda sir.
ಅವ್ರದ್ದೇನೋ ಕ್ಲಾಸ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರು. ಅವ್ರದ್ದೇನೋ ಕ್ಲಾಸ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರು. I don't know whether you will take or not. We will see.
Chadda sir. OCT and IVS will take this one. Before that, if you want, I can show some images.
Yeah.
This one, if you want on Monday, now tomorrow we'll take a leave.
Okay.
If you want, you can, that IVS and OCT picture I will show. It may be basic things, then Chadda sir will show, then we will, he will explain very nicely. Okay.
Okay.
One, if you want, I can show you that some pictures, some fiber blocks, calcium, everything. This one.
Okay.
Monday I will show you. So
Okay,
other than that, then now I will show some picture. This one, angiogram pictures.
When, brother?
Spotters.
Okay.
VST, PDA. This one you have to identify. You have to, because they will keep in the exam spot some TOF angio. VST angio, AST, what VST, it is the subpulmonic VST, subaortic VST, apical VST, TOF, and that TGA, TTGV. That angios I can show you, for that is for the spotter. That just you can tell what this angio is. That one class, I think that is better to take. I will this one. Otherwise, that is enough. One or two class enough, sir.
Okay, brother.
Monday,
we'll let you know Monday.
This one, I was sent OCT, and Tuesday I will take that spotters. Okay. This one, that the NGOs I will show you. I think you have a pediatric posting, everything you have finished, but still something you can be able to identify the views and all.
Yeah,
okay,
we'll see.
Then
we'll
end the session then.
Yeah, brother. Thank you, brother. Nice class.
Thank you.